Okay, guys, let us get started with Kafka. Even if you have not worked with microservices, it is okay. In this session, you will get a complete understanding about what is Kafka, what is the purpose of it, the use cases of where Kafka is being used. Then we will understand about the components of Kafka. That is, I'll go walk you through the Kafka architecture in detail. And of course, without microservices, we will do a simple example. If you guys are in front of the system, then I will help you out to do one simple example using Kafka. So this is the itinerary for today's session. The duration is 1.5 hours as you have asked for it. So initially it will be a little bit theoretical, but we will try to understand what is the meaning of event, what is event streaming, how exactly it is used in Kafka, what is the difference between traditional messaging system and this one. Then we will go into the key components of Kafka, what exactly are there, how it is done, and then we will move on for a simple example. So if you guys are in front of the system and if you are having Docker install, it is okay. We will try to download Kafka using Docker. I mean, pull the image using Docker. Or if you don't have Docker also, we will download Kafka. We will do a simple example. Provided you are having your system, you are sitting in front of your system. Okay? Yes. Now let us get started. Guys, any idea about Kafka? Anybody has tried working with that, tried using Kafka? You can answer me in the chat window. Yes, please.
Kafka is used in distributed, as
Mm.
I said, it will be used in microservices
Mm.
for live streaming the data.
Okay, very good. So for live streaming, for streaming of data, any example of Kafka? Any example? Real
Uh,
example.
a real example, like in Netflix, uh, if we
Mm.
search any movie, so it will suggest based on our interest.
Mm. Okay,
So
very
it,
good. Mm.
so it suggests based on our interest more movies
Yeah,
uh,
correct, correct.
related
Very good.
related to our interest.
Based on our interest, automatically it is going to stream those kind of movies in our feed. Okay. Then
And in Swiggy, Zomato example, like if we order something and suppose the delivery boy is getting the order from
mm.
restaurant to house. So
Mm.
the map every time it will be real time data it will be given.
Mm. Yeah, very good. Excellent. See, guys, actually, to start with, rather than going in for theoretical part, first we will understand. As you told, the best example is if you are ordering your food through Swiggy or Zomato, you always put track order. You want to know the real streaming, where this delivery guy is. 15 minutes, 25 minutes, 2 minutes, like that, you are seeing the real streaming. That can be achieved with Kafka. One other thing, easiest example I'm just telling you. Suppose if you are placing an order, you go to a site in an e-commerce application, you are placing an order for a particular product. Automatically, a notification comes to your machine, like to your mail or to your WhatsApp, saying that you have ordered this item. So these kind of real-time streamings happen can be done with the help of Kafka. There are two types of message brokers. One is like using RabbitMQ, the other one is using Kafka. Okay, one question is it for fresher? Actually, it is not for freshers, but if you get to know, it is well and good. As I told you, you don't need any experience for understanding this session. This session is purely from scratch. If you are a person who wants to understand what exactly is Kafka, how it is working, only for that purpose I have organized this one. Okay, basically, if you are a person who is working in Spring Boot, it is better that you understand Kafka, you should know how to interact between microservices using Kafka. So all that we will discuss now. Kafka is not only used with microservices, it is used with ETL, it is used with big data. What Rahul told, like it is used with big data as in, suppose say if I'm going and searching for certain items in my e-commerce website, automatically it is just going to give me suggestions based on that. Okay, more like this. In Netflix also you are getting it, right? So these are all done with the help of Kafka. And if I want to pull data from the database, for that also we are using Kafka. Okay, now let us jump in. We will first, don't feel that it is going to be theoretical. I want to have this as an interactive session. I will explain more about in detail about what exactly is Kafka. Try to relate it to real examples. Okay, so whatever I have given is based on the real examples only. Then after that, we will go in for the proper architecture. My dear guys, actually years before when I started with Kafka, 2020, I'm telling, I felt it is very difficult. But actually Kafka is not. If you can understand the flow, if you know what is the purpose of Kafka, meaning to say that the conceptual part, then the working part. We did, I mean, few days before, like in my batch, we did an example where when I order an item, automatically a notification will send to some other service, and from there a has to be sent to all the emails. So you will have to integrate your email service to your microservice. So those things also you will be doing in a real world scenario, in real world applications. Now for this particular session, we will try to do it with the console. So you don't have to install anything. You don't need anything. We will be doing it from the scratch. Okay. Now let us get started. Feeling sleepy, somebody? I'm muting everybody. Okay. Okay, first, let us get started. The first question is, what is event streaming? What is an event? The first thing is, what is an event? Okay, well, these are the topics that we are going to see now. What is event streaming? What is the use of event streaming? What is the meaning of distributed event streaming platform? And from there, we will move on to what is Kafka. What are the real use cases of Kafka? Then we will understand the Kafka architecture. When I say architecture, it is going to have certain set of components. Most few of you might be knowing it, like producer, consumer, blah, blah, blah stuff. What exactly it is? What is the purpose of it? Where exactly we need to use it? So all those we will see. Then we will do the theory part. Then I will take a short break. We will come back. We will do the installation and setup, and we will do a simple example. In the end, I will also show how you can what to say, through a microservice I will show you. But microservice, guys, we cannot do it directly as an example, but the other one we will do it from the scratch. Okay, now my first question, what is an event? So before jumping into event streaming,
Event is that which performs the action in specified time.
okay, any simple example, what is an event? Okay, this is an event. Webinar is an event, correct? Now, I'm just saying that I'm just going to conduct an event. Automatically, like whoever has registered for this event, they are coming to this event, correct? Similarly, in any application, there are many events happening. Like I click place order button, I click add to cart button, I register myself in a particular website. So these are all few events. Like, or in a stock exchange, I'm trying to buy something, like I click track order button. These are all events. When an event happens, I want to know what exactly I should do. There is a webinar happening, so you are trying to attend the webinar. So meaning to say that the moment you register, the information comes to you and you can attend the webinar. So when an event happens, there are few listeners who listen to the events so that they can register and they can just do some actions based on that. I am seeing this webinar, I don't want to attend it, so I will not register. I hope you can understand. So whenever there are events, there will be listeners. Whoever is listening to the event will get the data. Whoever is not listening will not get the data. That is a simple scenario. So what is event streaming? Event streaming means this data will be streamed from different sources, from databases, from sensors, from websites, from other applications. So this is called as event streaming. Now, when I stream an event, so this is actually what we are doing. What am I doing? I am streaming my video through Zoom so that others can access it. So because I have floated an event, you are accessing it. It is through Zoom. Similarly, when an event is getting streamed, it has to be captured somewhere. So the event streaming, it is going to capture data from many places. It will store it in a particular area. Whoever wants to access it, they will access it directly. Now let me just show you what is event streaming. So first is, what are events? A website click. I click an order place button. Cart updated. Temperature. Every time when you go to the, when you open your machine system, you see the temperature update. They are all real-time streamings. Loan approved. Email sent. I have received your email successfully. The moment you register, automatically it is configured in such a way that you get a message in WhatsApp also. If the delivery guy is delivering it to your place, automatically you are getting a message saying that your item is delivered successfully. So all those are events. There are listeners who are going to work on that. Event streaming is used to capture data from sources. So now my webinar is a source. Like that, you can get the data from databases, sensors, mobile devices, cloud services, software applications. Okay. Now, after that, now some event is getting streamed. If somebody cannot access it immediately, I want to store it in a particular place so that they can consume it later on. This is not synchronous. If I call you, automatically you are picking up the phone and answering me. That is synchronous. If I message you in WhatsApp, you don't have to answer me immediately. Later on, you will be answering me. This is asynchronous, meaning to say that the data is stored in between. So similarly, these streams, the event streams, they are nothing but messages. They are in the form of byte array. They are stored for later retrieval, for manipulation and processing. A simple example. As I told you, the user goes to an e-commerce site. He orders some item. He clicks on the place order button. The moment he clicks place order button, an information is stored in a server. The other service will take that information and send us a mail to the person who has ordered this item. So automatically the other guy will get a message saying that your item has been ordered successfully. So that is like a notification. There is an order service, there is a notification service. In between, there is a Kafka server where there is items are stored. Okay. The streams can be routed to different destination as needed. Now, please understand, I am a producer. I am just creating an event. It comes and it is getting stored in the server. So a simple example. I have a place order button. Now assume if it is a microservice or if it is any application, when I click place order button, once it is done, the details or this event details is stored in a server. Now, whoever is connecting to the server will consume the data. Now I can have one other application, maybe an WhatsApp or notification application. After getting the data, if I want to perform some other operation, I can perform that operation also. In case of notification, just send a mail. In case of payment, after the order is placed, what is the next step? You need to do the payment. So those details, those also can be consumers. So please understand, this is like a messaging system. Publisher, subscriber. Few people would have worked with publisher, subscriber. This is from year-old one. Even in Java, you are having an design pattern which is called as observable design pattern, where there is a publisher and a subscriber. Okay. If I want to call you, I can call you through a phone. So I am a publisher, you are a subscriber, one to one. So earlier it was called as a queue. One producer, one consumer. I send you something, only you can consume. Now even in Instagram, you are having broadcast. Even in WhatsApp, you are having group call. I call, many people receive it. It means one to many. So in that case, it is called as topic. I hope you can understand. There are two things. One is queue. This is a very, very base thing. This is from Java, good old Java itself, it is available. Java messaging services, they also use the same thing. Meaning to say, there are two applications. Say application A and application B. Now application A wants to send something to application B. It is a request. Application B has to return the response immediately. This is synchronous. You ask for something, you get the data. But I want real-time streaming continuously. That has to happen within milliseconds. So for that, we go in for publisher and subscriber model. So this is your publisher and there will be a subscriber. If in this, there are two things. One is like one-to-one, one publisher, one subscriber, or one producer, one consumer. Once the consumer consumes a message, then the data is gone. How do they communicate? The data is stored in the server. The publisher or the producer stores the data in the server, which can be RabbitMQ. Okay. And the consumer will consume the data from that particular channel. If you are calling me, I need to call only you in your number. So only through that channel they will call, that is queue. Now, one publisher to multiple subscribers, if I want to do, then we will be putting it in topic and multiple consumers can consume it from the topic. This is a publisher subscriber model. This is already there. This has been used years before also. This is used for asynchronous messaging. Whenever I want to do streaming of messaging, asynchronous functioning, we need to use publisher subscriber model. Kafka also belongs to publisher subscriber model. But the only thing is, in this case, the data will be stored for a period of time for later retrieval. Here, once the data is taken by the consumer, it is not available for other people. But in case of Kafka, it is not like that. It is stored for a period of time so that again any other consumer who wants to consume can come and take the data. So this model is actually a publisher subscriber messaging system. Okay, this is the base. If you talk about Kafka, this is the base. So it uses internally it uses a particular pattern. Now, in Kafka also, you have a producer. And the producer can be any kind of application. It can be a microservice, it can be a mobile application, it can be an IoT device, it can be a sensor, any device. After capturing the data, it is going to store the data in a server. This is called as your cluster. Cluster means group of servers, guys. So there are many servers. One single Kafka server is called as a broker. This is a broker. Okay. So in one cluster, at least you will have 3 brokers. Now the producer is producing some data. He is storing it in the broker. Now what about the consumer? Again, the consumer can be any type of application who wants to consume the data. It is not necessarily only for microservice. It can be for any kind of application. The consumer can be a normal consumer, or it can be a database, or it can be an elastic search. Okay, or it can be an IoT device. It can be anything. So you have a producer, you have a cluster, you have a consumer. So this is the base architecture of your Kafka. Now let me go back. So the streams can be routed to different destinations. Destinations can be anything. Even streaming is for continuous flow and interpretation of data. There are many examples that you can relate it. When you are booking a cab with Uber or with Ola, you want to know where the driver is exactly. That is again streaming. So when I am just checking where exactly the track the driver, automatically whatever you are seeing is streaming. Immediately the data is coming in. So event streaming where and all you can use to process payments in real time. Immediately I just add amount when I click. So after I am paying, immediately I am getting an acknowledgement saying that that is the consumer who is consuming the data and giving it to me. To process transactions in real time in stock exchanges. Assume a user goes to a trade center, he wants to buy a stock. Automatically the matching stock is identified, given to the user. The user buys the stock. immediately whatever is share his amount, everything will be given to him directly within milliseconds. It is actually real time streaming. What is the price, whether the price is increasing or decreased. So all that real time streaming happens. So for that also we will use event streaming. Track and monitor trucks, Ola, Uber. Continuously capture and analyze the sensor data. I want to see the temperature now and then immediately. To monitor patients in hospital care, to check in for their ECG, to check in for their BP, all that to predict the changes. Based on that, the graph has to be given immediately. To collect immediately and react to customer interactions. Your LinkedIn, based on your user interaction, it is going to provide the feed. In Instagram, based on your wish list or your choices, it is going to provide only those kind of feeds. All that are examples of event streaming. It happens in real time. It is checking what are the Instagram reels that you're watching. Based on your interest, it is going to provide recommendations. Now we are talking about Kafka. Kafka is a distributed event streaming platform. It captures, processes, stores. The data will be stored in Kafka server and it transmits the events. When I say event, it is actually an event happens. Some data comes in. What is the data? It can be a record. You can call it as a message in real time, and it is sent to multiple other applications who are all called as consumers. What is the advantage? It provides high throughput in and fault tolerant for scalable applications. Now let us talk about Kafka. Already I have told you it is an open source publisher subscriber messaging system. It sends messages between processes, between applications, between servers. It's like an event log. Whenever something happens, it will be appended to the log. It's like a commit. In your Git, you commit item, commit, right? So just like a commit log, you will have event log. The messages are added to a disk for a period of time. That is the difference between RabbitMQ, traditional message brokers, and Kafka. In case of traditional message brokers or traditional messaging system, once the data is consumed, it is in memory. So you will not find it for the other consumers. But in Kafka, it is not like that. We will see with a real example. Any questions? Any questions?
Ma'am,
Nah.
actually, like you are saying that a producer produce some data and the
Ah,
data will go to the server like message broker store.
ah,
But
ah.
how that consumer will know that data is produced and a consumer will read that data because we are not making direct call.
That is the beauty. That is the beauty. Actually, see here, one simple example I'll tell you. There is a microservice application. There is a service. If it is a order service, meaning to say that even if you're not having any idea about microservice, it's okay. There is an application where when the end user places an order, it comes to this application, meaning to say that an order is placed. So those details, what is the order that is placed, that is sent to the Kafka server. Means the data is stored here, meaning to say that this product, these many number of quantities, this for this particular price is ordered, and I'm storing the data here. Now what about the consumer? For whom should I tell? Actually, now when somebody is ordering some 200 pens, it means the inventory or the stock of that particular pen has to be reduced. So I will be having some service which is called as an inventory service. And to the user, I need to send a mail saying that your order has been placed successfully. So assume that there I am having few other services, notification service, product service, this service, so many things are there. Now, as you ask for, how the consumer will know that actually I need to get it. Suppose, assume that you don't have a concept of Kafka messaging at all. In that case, what happens? It is mandatory that this inventory service has to make an API call, come and check in the service. Suppose I am having two services, A and B. Now, A is doing some work. B has to know that whether A has completed it or not. It means that it is mandatory that you need to make an API call.
Yes.
Making an API call means it is a waste of resources. But it is something like, okay, you are all working. you are working in your projects. What you do after you complete, maybe you update your log or you update your Excel sheet, whatever you are having, so that the other guy who is working in your team will get to know what has happened. If you don't update, it means he has to come and ask you what you have completed, and then he has to proceed with that. But if there is a centralized place where you are going and updating your worksheet or your work details, the other person, how he will get to know? He will come and check whether about the details. Assume there is an Excel sheet, a simple Excel sheet, work log. A and B are working. A is coming and updating. B and A are in the same team. So B will come and check in the work log whether there is data, and automatically it will consume it. It is not an API call. B will be listening continuously. Guys, whenever you are connecting to somebody, you are sending a message in WhatsApp, you will be waiting for the answer. You will be continuously checking whether you are getting the answer or not, message or not, right? So similarly, B will be continuously listening to it. It is not that B has to make an API call. You are not calling any method at all. Automatically the listening happens. How do we know that I have to connect to this particular thing? That is why they have come up with something called as topic. A is going to send the data to a topic. This is a topic. Okay, so A will store the data in this topic. The topic name is my topic, something like that. So what B will has to, inventory service and notification service has to do, they have to listen to this continuously, so that if somebody has placed the order, automatically the stock in the inventory service will be reduced. Automatically the notification service will take the message and send a mail to the user saying that your order has been placed successfully. It is not an API call. The consumer, only if he is listening to the server, he will get the details. So this is very important. I hope it is clear.
Yes, it means like inventory service listen some order request and it will
Exactly.
perform. It
Exactly.
will perform
Exactly.
operation.
See, the beauty is when you are working in a microservice application, you suppose say I have a product catalog service. Okay. I have a product catalog service. Now the user wants to order. So what actually the user will have to do? First, he will add it in the cart. So now I'm having a cart service. I'm having a product catalog service. So now what I need to do is, whenever I'm adding items to the cart, first I need to get the products. So here I'm making an API call, a proper call. I get the products. I see the products in the front end. So it's all with relevant to the front end. First I make a call. So this fellow will go somewhere and he'll call product catalog. Then when I click add to cart, it will come here. From here, it will make an API call to product catalog. The items are getting ordered. So it means every time you are making an API call. Now finally, this person decided that he will place an order. The moment he places an order, automatically the Kafka, when I click this button, it comes to order service. Now when it comes to order service, what is the next step I need to know? Somebody has ordered some item for these many quantities. It means the inventory has to go down. So actually, technically speaking, inventory service, what it has to do? It has to make an API call, check what is the quantity, and it has to reduce it. But it is a waste of time. Every time this fellow cannot go. Millions of people are just coming and ordering. Every time he cannot go and make API calls. That is why once somebody has ordered, the order service will create some information and he will put it in a server. That's what I said. 10 people are working in a team. You guys all are working in the same team. Now, every person cannot come and ask the other person what you have done, what is the status, how much you have completed. You might be having a proper process where you are adding the details in an Excel sheet or somewhere you are storing it so that everybody gets to know what the other person has completed, right? I am out of your team, so I don't know what is happening in your team. But if I am also listening to your particular work log, I will get to know. Similarly, this product catalog cart service is not a proper, they are not going to listen to the server. Who is going to listen to the server? Inventory service. The moment order is getting placed, this order service will add an event saying that, see, I have some order has been placed. This is the quantity. This is the detail. Some message it has saved it in the server. Some simple information has been saved in the server. Inventory service is listening to it continuously. The moment it sees that an order is placed, automatically in inventory service, it will be reduced. I'll show you a very simple example. Similarly, to that notification, I can create a notification service. This also is going to be listening to continuously to the server. See, inventory is having few other purpose also. Now there is an admin. He wants to add new items. New stock has coming in means that is behaving separately. But what is the connection? The connection is when something happens, it is going to add it to the server. Okay, now in a Kafka server, what will be there? There is something called as topic. We will discuss about that. And you give a name for a topic. Suppose say I am giving it as order topic. What happens? Order service will come and add the details in order topic. Inventory service is listening only to this particular topic. It will get the data and consume it. Whatever is there, it will consume it, it will behave accordingly. It will do some manipulation. It has to reduce the stock in the database. Those things it has to do. I hope it is clear.
Yes, yes.
So it's not an API. That is a real beauty. Now you click track order. It means the moment you track order, some messaging is going to the Kafka server. And actually from Zomato, this guy is coming towards you, towards your home. So he is sending the details continuously. When you click track order or when you are clicking that button, it means you are a consumer. You are consuming the data and you are checking where this guy is coming. Okay. So yeah, Kafka is a streaming platform to collect, process. So it is a single place for storing and distributing events. It has got a numerous use cases. What it is, you will see. What is the advantage? High throughput. Everything happens in millions of events of per second. Like all it is under milliseconds. Distributes data across multiple servers. Guys, if you still feel it is more theoretical, the moment you start the architecture, you will feel it good. Okay, allows real-time processing and storaging of events. Where and all it is getting used, you will be seeing, actually it is nice. Supports multiple consumers reading the same event stream simultaneously. That's what. Netflix is streaming, LinkedIn is streaming. You and I, we both are seeing the same data in LinkedIn. Means somebody has posted, we both are following him, means obviously we'll get that data, right? So those things are all, it means multiple consumers can read the same event. That is why they are having it as topic. In older publisher subscriber, queue means one-to-one. Topic means one-to-many. Publish to many subscribers. Okay. What are the use cases? Real-time data streaming, event-driven microservices, log aggregation, big data, messaging system replacement, streaming ETL. Okay, what is real-time data processing? Fraud detection. If bank is analyzing a transaction, if it sees that there is a fraudulent activity, immediately it has to send a message to the user. It means the user service is continuously accessing bank. If something happens, automatically the message comes to you. It's like broadcasting messages. You have seen broadcasting messages, right? From somewhere from the server, you all are getting it. Stock market analysis. Already I told you. Streaming stock prices freshly. So NASDAQ, wherever you are seeing, everywhere it is using Kafka, a streaming messaging system. Live, the price is getting changed continuously for each and every stock. When the user is buying it, immediately it is getting streamed and the other seller, whoever is selling it, is getting the price. IoT data processing. IoT, this is for all the devices. I want to check the sensor, whether the battery is low, whether the battery is full, or I want to check whether it is working properly or not. For those information also, this is for smart devices. You might be using, what is that, washing machines. You might be using iRobot for cleaning your house. So for that also now we are using mobile devices. So the moment it has completed the cleaning, it goes and goes to the dock, means automatically a message comes to you, the machine, the user's mobile. The robo has completed the cleaning. How it is possible? I am not going and checking. The moment it completes, a notification comes to the user mobile. So that is IoT data processing. Social media feeds, I don't have to tell it. You all know, processing live user activity feeds. So for all this, we can use Kafka server. Only thing is, the producer, it can be any kind of application, he is sending data. Consumer is one, whoever is listening to that particular server, to that particular topic. From that, it is going to consume the data. Okay. Event-driven microservices. This I told you. Order processing. When an order is placed, Kafka sends an event to the event, inventory, payment, and notification. Automatically, because these three services are actually they are listening to the service. User registration. When a user signs up, triggers welcome mails. You are getting welcome mail and analytics. You all registered to Zoom. That's all. Automatically a message. So it means some other service is capturing it and sending you a notification. E-commerce work for cart updates, payments, delivery tracking. Wherever there is asynchronous data processing, in all those areas, you can use Kafka data streaming. Why? Synchronous means when I click something, immediately I want to see the data. Like I'm searching a searching a product by brand. I type Samsung. When I click submit, that is a proper API call. I am asking for something, it goes to the backend, gets the data, comes back, and it is showing it to me. Okay, but the second part, that is for calling directly the API. But after I have added the item to the cart, or if I'm canceling my order, immediately a notification comes to my mail because my mail is registered. Somebody is listening to that information and it is sending the data to my mail. Okay. Log aggregation for application logs, for system monitoring, for all that you can use Kafka. Logging also is very important. All the log messages. In cloud computing, multiple servers are involved means I want to know where exactly the error is. So to identifying the faulty machines, I need to use the logs. That can be also taken care by Kafka. In big data, see, Netflix, you told Rahul, right? Analyzes real-time user behavior to recommend content. So, as I told you, wherever you are using asynchronous applications, like for all that places, you can use Kafka. In this one, processing user activity for personalized recommendations. This is done by Flipkart and Amazon. So based on your choice, based on your interest, it is going to show you those kind of items so that it can be. So how it does? So the moment it is taking, all these are captured as events in the Kafka server, and now as a user we are going to consume it. Okay. Who are all using Kafka? You told Netflix, Uber, Twitter, PayPal, LinkedIn. LinkedIn is for feeds, powering feeds, notification, and real-time analytics. Okay. This is the Kafka architecture. So there are many producers who are going to produce data, send the data to a broker, then there are consumers who are going to consume the data. Now, what are the things that I need to understand in case of Kafka architecture? First is you need to understand what is a producer, what is a cluster, what is a broker, then consumer, then other than that, you have got something called a zookeeper, topic, and partition. Yeah, now, okay, now let me just tell you this first. First, actually, I will explain it and then we will go into the slide so that it will be easier for us also. One minute. So, in case of a Kafka server, it is a publish subscriber system. It is a distributed event streaming platform. So here I have producers. The producers are going to produce the message and they are going to store the data in a broker. What is a broker? A broker is a simple Kafka server. You will not have one single server. You will have multiple servers which are in the form of cluster. This is the first thing. So this is my broker. And this is the cluster. To manage all these brokers, we have zookeeper. To manage all these brokers, we have Zookeeper. So each broker is nothing but a simple Kafka server. And in a cluster, you should have at least minimum 3 to 5, I mean 3 min max 5 brokers to handle the input, that to handle the events that are streamed by the producers. Now the data will be consumed by consumers. You can have similar consumers and you can form them as a group of consumers. So you'll have a consumer group. Consumer group in the sense something relevant to order will be a consumer group, relevant to payment will be a consumer group. If one consumer in the group has consumed a particular data, the other consumers will not consume it. This is to avoid duplication. Okay. Now, what does a broker have? In a broker, so, okay, first thing, what do we send from the producer? We are streaming an event. It means we are streaming an record. What does it have? It has a message. Okay, technically it's like a key value pair, but it has a message. So what is there in the message? The message is in the form of a byte array. What are the items that are there in a message? It has a key, it has a value, it has a timestamp. Suppose say if you want to compress the data, you are sending more data, means the compression type, then yeah. So one more also is there. So key, value, timestamp, what is the compression type? Key is optional. It is not mandatory though. Value is the data or the event that you want to store. It is nothing but some object. This user has registered successfully, or you want to send order details, or you want to send the location, the GPS location of that particular driver who's coming to your house. So those kind of information is available in value. Timestamp is when the event is created. So this also actually will be a part of Zomato, like when they are sending the driver, he will reach you in 5 minutes, 2 minutes, like that. Then compressed. If you want to compress the data, how it will be? The data can be in the form of JSON, the form of XML, the form of RO, ARVO, or protobuf. RO is an open source framework which helps to send data in the form of JSON. Okay, so this is the message. So a producer is going to send the message. Where it is getting stored? It will be getting stored in the broker. In a broker, you have topic. A topic is like a logical channel. A producer is producing the data. It will be stored in a topic. The consumer will consume the data from the topic. The topic name has to be unique. In one broker, you can have any number of topics. There is no limitation at all. You can have as many number of topics, each topic having a unique name. Now, in the topic, you will have multiple partitions. So now I have one single topic. I have partitions. So I have partitions like this where the message will be stored. This is my partition and the message gets stored here successfully. And whenever a message is getting stored, it will be given an ID, an offset ID. Suppose say the first message is coming here, means it is getting stored in partition 0. The ID will be 1. Then the offset ID will be 2. The offset ID will be 3, 4, 5. Then again partition 2 offset ID will be 1. Like that. So each partition will have its own offset ID that you need to understand. Partition. So it means one broker can have any number of topics. One topic can have any number of partitions. The message will get stored in these partitions. And when the message is getting stored, you will have the partition ID. Sorry, offset ID, which is nothing but the increment ID. Just like in a for loop, you increment the increment ID. So the consumer, okay, how the producer will know where to store the data? Now there are so many partitions. How the consumer will know that where to store the data? Suppose if you are providing a key, I am sending data relevant to orders, or I am sending data relevant to sensing the temperature, then it is mandatory that I need to provide a key. Suppose I am sending the key as order key. It means it will understand, okay, all these messages are relevant to orders. I have to put it in the same partition. The message will be stored in the same partition if you are adding a key. If you don't provide a key, what it will do is, if you are providing only value, means the data that is sent by the producer will be randomly stored in different partitions. Usually it will be in a round robin fashion. It will not bother, okay, I have to store it in this particular partition only. One thing you can ensure that the messages will be stored in a sequential order. 1, 2, 3, like this sequential order it will be stored. But if you are giving the same key, like my first message is coming from orders key, so it will be stored in partition 0. Then I am sending a message without any key. It will be stored randomly. The third message is also coming with the orders key. It will be stored in partition 0 again. So the producer, if he wants to store properly, first, before sending a message, he will go and check, get the data, metadata information about the partition, about the keys. Then only he will start sending the messages by adding a key. If you don't add a key, the messages will be stored in the partition randomly. This is about the partition. We will see in detail from the slide. What about the consumer? How does the consumer consume it? When now I have started sending the messages are till this part. I have completed till this part 4. Now a new consumer is coming in. Now the new consumer who is coming in, he will start getting the data only from this particular ID. That is from the second one, from where the producer has given. But what if I want to consume from the first? There are few attributes. If you say that I want to consume from beginning, automatically the whole data will be given. Okay. Now this consumer has consumed. Is there, see, I told you there is an inventory, there is an notification. Both of them are going to consume. If this consumer has consumed it, what about this fellow? Whether he will be able to consume it? Yes. You can have any number of consumers consuming the same event streamings or same event streams. But there is a problem. If they both belong to the same consumer group, they cannot consume it. Okay, this is about consumer. Now, let us see this in detail. So, what are the things that you need to know is, what is a message? Who produces the message? That is the producer. Then, where does the message go? The message goes to a broker. Where does the broker sit? The broker sits inside a cluster. What does a broker have? The broker has a topic. The topic has its own partition. And one thing I missed it, I will show it directly from the picture. Whenever you are creating brokers, like just like duplicates, you would have heard about replication factor. So here also you will have replication factor. See, I'm having broker A, that is one server, server 2, server 3, broker A, broker B, broker C. In this, I'm having one topic, topic 1. In topic 1, I have got 5 partitions, partition 1, 2, 3, 4, 5. Now, we will add a replication factor in partition B also. Means for this one, I will add 2 more. This is topic A. I will have topic B also. It will have its own thing. And remember, for all the partitions, there will be a leader. Who will decide the leader? Zookeeper. So, zookeeper is responsible for managing the brokers in a cluster. Zookeeper only will do the leader selection. If there are multiple, okay, what is the purpose of replication factor? A producer is trying to send the data to topic 1, partition 0. Now the data is added. Now again he is trying to send the data to topic 1, partition 1. Now this is a failure, but he has to send the data. What he can do is, it will be available in broker B as a replica of topic 1, partition 1. We are creating some replicas so that when some broker dies, you can get the data from the other brokers. Just like how we have Xerox copies, it is same thing here also. We are having replica factors. If the replica factor is 2, means I'm having one leader who is the original and one replica. So totally the replication factor is 2. I hope you can understand. So these are all partitions. For one partition, I'm having the same partition in the other broker. So the replication factor is 2. I hope this is clear. Okay. Zookeeper, consumer. Then there is consumer group. So these are the components that are there in Kafka. These are the things that you need to know. Now, let me just go back quickly. We will see this. You will get an idea. So, producer sends messages to Kafka topics. Broker, a single Kafka server that stores messages and manages topics. Cluster, it should have at least 3 brokers. Zookeeper, it is used for managing the cluster metadata, taking care of the leader election, all that will be taken care by Zookeeper. That is all the topic configurations. Topic, a channel where the messages are categorized. Partition, you divide your topics into multiple partitions. The data will be, or the event streams or the records, they will be stored only in the partitions. Consumer reads messages from Kafka group, a group of consumers working together. We'll see it one by one. So what does a message have? Message is nothing but a record. It is in the form of a byte array. It has a key, value, timestamp, compression type, headers. It is also optional. This is important, offset ID. Every message has an offset ID. Why? Suppose I am adding a message, means automatically the offset ID is 1. Now when the second message is coming in, it will check the offset ID. Now it is 1. It will go and sit in the next place, offset ID 2. It will go and sit in the third place, offset ID 3. What is the purpose of it? Now, if the consumer is consuming, assume he has started consuming from 1, 2, 3, 4, he has consumed. Then now the consumer stopped consuming. The producer is going on adding data. Now it is available. The consumer has the offset ID till what he has consumed. He knows that, okay, I have consumed till 4. I have to start from 5. And he will start consuming from 5. So that is the purpose of this offset ID. Just like an ID, so that the producer knows where he has to put the data and the consumer knows from where he has to start consuming for that purpose. Okay, a broker. So you can quickly read through it. See, have a look. It's a single Kafka server. It receives messages. It assigns offset, committing messages to the disk, means to a server. It is asking the consumer to fetch the request and serve messages. One broker instance can handle hundreds of thousands of reads and writes per second. Everything happens in milliseconds. That's what. If a trader wants to buy a stock, he just goes and checks for the matching records. All that will be given to him. When he sends that, automatically it will reach the other seller who will be a consumer. I am a buyer. The data is getting saved in the Kafka server. The seller is going to retrieve the data. Okay.
And madam, when you say offset, where it will be configured, madam?
You can provide the offset value by yourself, or automatically Kafka will create an offset ID within the partition.
Okay.
Okay. So when you are okay, now I'll tell you. You are creating a topic. First, what is the first step is? I need to create a topic. While creating the topic, I have to tell how many partitions I want. I say I want 5 partitions. Number 1. Then it will ask how many replica factors you want. So I say I want these many replica factors. Replica factors means including the leader. 1 leader, 2 replicas means the replica factor is 3. You have to provide that.
So
Then,
replicas will be created inside the topic itself?
yes, while creating, so you create the topic directly from the command line, you create the topic. See, there are 2 ways of doing it. We are doing with relevant to Java. Even if you see Confluent, through Confluent, you have a UI. With the UI, you can configure it. You can do it from the command line. You can do it from a microservice application. If you are doing it with Confluent, you have a UI. You go and add all your details. This is the offset ID that it has to start. What is the partition you want? You can just tell, see, I am adding this message, hello world. Go and sit in partition 1. And what is the replica factor that you want? All those details we can give it in the GUI. In case of command line, what you will do is, while creating the topic, you will provide these details. What should be the partition, or how many replica factors you want, what should be the offset ID. With that, you will create the topic. So the offset ID will start from that. When you go on adding messages, the offset ID will automatically increment.
Okay. Replicas also configured through command line
Exactly,
commands.
exactly. This is with command line. Now you are working in a microservice. In that case, add all that detail in the YAML file. That's all. All these configuration files. What is the key value pair? Actually, Kafka sends messages in the form of a key value pair. What is the key? What is the type of the key? What is the type of the value? Key, dummy name, whatever you are giving, that is the dummy name. Value, what is that you are going to send, store in the Kafka server? It can be a string. It can be a object, a domain model. It can be an integer value. It can be anything, list of strings. It can be list of objects. It can be anything. So you need to configure the serializer, which is of type string. That is the key. The value, it is JSON serializer. So all those configuration details relevant to your topic has to be added in the YAML file if you are working in a microservice.
So when we add offset value, everything in the YAML file, we need to pull up using @value while writing the code.
Exactly. Exactly.
Okay.
The topic name, the offset value, everything you can just retrieve it using the at value annotation.
Okay.
Okay. So in topic as we have discussed, it's a channel. It is by its name, it is unique. You can have any number of topics. Once a message is published, the data cannot be changed. Zookeeper, this is very important. Actually, I'll tell you one of my experience. Years before, that is, I remember 2019 or 2020, during that COVID time only, I was doing this training. So first they said like you need to download and install Zookeeper. So I downloaded and installed Zookeeper. Then download and install Kafka. So I downloaded and installed Kafka also. Now I tried running Zookeeper. Zookeeper ran. I tried running Kafka. It was not running at all, literally. So 2 to 3 days I was debugging. So you won't believe what is the mistake, When we download, when we are installing, what do? We try to give names for our folder, right? So when you try to give a name for your folder, I gave it as Kafka space installation. Because of that space in between, it was not able to run Kafka server at all. It was to identify that error, it took me literally 2 days. Why I'm telling means there was no, I couldn't find it in Stack Overflow or anything. 2 to 3 pages of Google, I just moved on. Only then I was able to identify somewhere somebody has given it. Similarly, now also you have the same issue. When you are downloading it, downloading Kafka, many of you have the problem that you go and add it in desktop. I have seen many people, what they do is when they are downloading something, they directly download it to desktop. So what is the path? Now it is C drive, users, your name, Sripriya, desktop in that, your name is Sripriya, right? Desktop in that Kafka. So the path is huge. It will not run the Kafka server. So that is one important thing that you need to know. Okay, so what is the purpose of this Zookeeper? It is for managing and maintaining the brokers. Okay, it assigns a broker as the leader of a given partition and topic. So as I told you, when there is a topic, you have many partitions, means one partition will be leader, the other party, the same group of partitions will be replicas. Whenever a broker dies, it has to do leader election, identify the other partition as leader. It stores traffic configuration, it sends notification to producers and consumers if there are any changes. That's what broker failure. Suppose if one broker fails, now immediately Zookeeper will inform the producer. So the producer will not put the data in that broker. It will go in for the other broker in the replica partition. A cluster can have multiple Zookeepers. Okay, see guys, this is how the partition will be. See here, messages are stored in the sequential manner only. Each message is assigned an increment ID, which is called as an offset. There is always no guarantee in which way the messages will be stored. If your message is having a key, all the messages with the same key will go in the same partition. If there is no key, the data will be written randomly. Okay.
So every partition will be associated with offset value.
Exactly. Every partition will have offset values. So in partition 0, this is my offset value, one message. Offset value 1, the next message. Offset value 2, the next message. These are all offset values.
So this offset value will be stored in Zookeeper in case the the broker is down. The producer will go to Zookeeper and identify the offset number
And then okay, so if this partition, assume that these partitions belong to a particular broker. If this broker itself is down, so zookeeper will say that this broker is down, go in search of the next partition, next broker having this partition as replica. The producer wants to store the data here. Okay, he has to store the data here in this place. Now, at this particular point of time, this broker goes down. So, can you understand? So, now it is 6. So, what it will do is it will go to the next broker, checking in for the replica partition 0, and it will go and store the data after 6, which is in 7.
When the broker is down, do we have any retry kind of mechanisms, ma'am, in Kafka?
In case of Kafka, the retry mechanism, I have not tried it. Actually, once the broker is down, you cannot try it again. Maybe later on, this I have not tried it out. I will check it out and I will tell you. This I have not tried it. The broker gets down when the number of requests or when the number of event streaming goes up or if it is high. So during that time, the broker goes down. Then automatically the zookeeper informs the producer. So the retry mechanism, maybe I will have to check it out. Okay.
How the leader will know that the broker?
I think broker, the retrieval mechanism is necessary because in every broker, same partitions will be available.
No, actually,
partition 0 available in broker 1, broker 2, broker 3.
Replicas are available. No.
Yeah, replicas are available.
Yeah, but the question what he asked is valid. So what he is saying is like the broker goes down. There are other brokers available with the replicas. But now, if this particular broker goes down, now automatically the producer will be sent to the second broker where you are having this topic. Actually, the same topic with the same partition. But this is a replica. Now the question is whether this broker will be put back again or what will happen to this broker. I will just let you know. I'll just check. We'll have a break. No, during that time, I'll check and I will let it. So
and
same
what
thing.
about the data in that one? Is going to be synced with that one? If it is down?
Data will be, replicas means obviously it will be same. Now, if at all, if there is a mechanism, if the broker is up and running, then what will happen is whatever is there in the replica will be again transferred to this particular leader. So that is the mechanism. See, I am having topic A, partition 0, which is a leader here. Here it is a replica. Both will have the same data. Now assume this broker goes down. Now the producer wants to store the data. The producer automatically will go and store the data in this broker only because the first broker is down. In the same replica, it has to store the data. Now what happens is, if the broker is up again, in this scenario, whatever data is available in this replica should be available in this partition also. Now this leader is gone. So automatically zookeeper will do a leader election to identify the replicas whichever is available to make them as leaders. I hope it is clear. This is a leader. The leader itself is gone. So the zookeeper will conduct a leader based on the topics. It will create a leader election. It will pick and choose one particular topic as a leader. Now assume this is the leader. Now if this broker is up again, then whatever data is there in this leader will be replicated in this partition, in this topic A, in this partition. The partitions, whatever partitions are there, they will have the same data. Replica data will be same.
Okay.
Yeah,
Is it mandatory to have a multiple brokers in a cluster?
Repeat it, please.
Is it mandatory to have a multiple brokers in a cluster?
Yes. Why? Because if you are having only one single broker which is taking care of multiple event streamings, then the throughput will be reduced, number one. The resource usage will become high. So to avoid that only, we are having multiple brokers, number one. Number two, in one broker, you can have multiple partitions. If one partition goes down or one topic, I'm having many topics. Assume I'm having 100 topics. In that topics, if 5 topics goes down, what about the data? The data is gone. That is why we are having multiple brokers with replica factors. Means whatever is there in broker 1 is available in broker 2 also. If I am not able to get it, I'll go to the other broker having the same data. It is mandatory.
Is there any limit in selecting the replica factor, ma'am?
In the replica factor, by default, you should have 2. If based on your requirement, if you are giving more replica factors, the resources will be more. So you maximum you can have 3. Just like how they are saying for brokers, it has to be 3 to 5. Replica factor for one partition. For this partition, it is better to have maximum 3. Not more than that.
What if it is not able to select if the leader is gone? What if it is not able to select the other things?
It is possible
So-
because that's a replica. See, what actually the producer will do is, the producer has to send the data to the Kafka server. Before that, what it will do is, it will go and call and check for the metadata configuration. It will check for the partition. It has to store the data. When you want to send data from a producer to a server, you will give only the topic name, what name you have. So you will give only the topic name. So the producer has to go and check whether that particular topic with that particular partition is available. If the broker is down, it will get the metadata configurations. If that particular broker is down, automatically it will go in search of the same topic with the same partition in the other broker. Getting it?
And one more last thing, like, do we have any dead queues concept here?
No, you don't have it. You don't have it. And one more thing, even if the consumer is consuming the data from the same topic, the other consumers also can consume it from the same topic. So here the concept is topic, meaning to say that one producer, it's like broadcasting, multiple consumers. Only one thing is, if one consumer is consuming within the consumer group has consumed the same data, to avoid replication, the other consumers cannot consume it. That is the only thing. So here, okay, just have a look into it. I hope this is clear. Just have a look into it. A publisher, okay, others already told you, it will partition data in round robin fashion. Before it is sending records, it has to send request metadata about the cluster from the broker. The metadata contains information about which is the leader for each partition. So based on that, it is going to do it. Now remember, the data will be returned to the partition leader. Then the leader will send the data to the replicas. I hope it is clear. The data will be sent to the replicas. Number 1. If that particular broker dies, Zookeeper will come up. It will make one replica as the leader. Now the producer will write the data only to that leader. Once if the other broker, as you asked for, if it is rectified, then that will become a replica and this data will be transferred to that also, replicated to that also. I hope I am making sense. I will repeat it here.
What if the consumer are going to consume the data from the only single replica or multiple replicas at a time? All the consumers.
One replica. A consumer can consume only one from one replica at a particular point of time.
No, not only one consumer, like multiple consumers. Are they going to consume from one replica or?
See, multiple consumers can consume from the same replicas, from the same readers at the same particular point of time. That is the beauty of streaming. Okay. You are seeing the same data in LinkedIn, what I'm seeing, right? So means the data is getting streamed. You are seeing the same reels. I'm also seeing the same reels. I'm a consumer. You are a consumer. So automatically the data is stored. I mean, the Instagram, somebody is putting the reels. It is coming to the server. It is sitting there. Both of us are seeing it at the same time. Streaming happens at the same time, right? So it means consumers can consume the same data that is produced by the producer at the same time, simultaneously. That is the difference between the traditional messaging system and this one. So producer will go and check for a leader and try to get the data. So it will go and check for the leader. If the leader is available, it will go and add the string, add the record. Now, suppose if this leader is down, then Zookeeper will come up. Assume this is in broker 1. Now, Zookeeper will come up. It will take that, this is broker 2. It will identify this replica of, assume this is in partition 0. This in broker 2, Zookeeper will make this replica as leader, as partition 0. Now, when the consumer wants to store, he will go in search of a leader. Broker 1 is down. It has got the metadata information. So, the producer will store the data in this leader in partition 0. If this is having a replication factor, in broker 3, The data will be replicated in broker 3 in this also. The data will be replicated. That is okay. What about this broker 1? If this broker 1 is up
So
and
where
running,
this metadata would be stored, like in order to for a producer to identify that particular broker, so it should have some metadata, right? This is
yes.
so where it will be stored and where the producer will get that metadata from.
From the header details, the producer can get the metadata details. From that, it will identify what is the offset ID, what is the topic name alone we will be providing, and what is the partition to which it has to store. And of course, the producer will have the key. If it is having the key in the sequence, it will be stored.
So when you say header, we will write a code for header, HTTP.
In the message itself, we will have the header. So when the data, so these details will be taken from the Zookeeper. You need to add the configuration in Zookeeper. See,
Headers as well.
yes. In the YAML file, you need to provide the configurations for the Zookeeper, saying that Zookeeper is going to have all these details about the broker and everything. So these details will be added in the Zookeeper, and this producer has to read the data from the Zookeeper, identifying what is the offset ID, what is the broker, what are the topic alone we will give. Producer, as a developer, you are not going to write any code, but in the YAML file, you need to provide properties for Zookeeper and properties for your cluster details. The offset ID, the topic name, everything you need to provide here. So
Header,
the producer
everything.
is going to get the data from there and it will proceed.
Okay.
And one more thing, like as you told, like if the broker is up and running, now this is not a leader, this will become a replica. Because this is a replica, whatever is there in the leader will be automatically copied to the replica. This is again, whatever is there in the leader will be automatically copied to the replica.
Ma'am, I have also one doubt. So like in synchronous communication, we are making the request and getting response. So if something went wrong, like we should troubleshoot, we know that what is the exact, we check the log file where it went wrong. But here both are the consumer and producer both are independent. Producer just produce the data, and he is not worried about the consumer is consuming the data or not. If something went wrong, how we will know like where it went wrong? How we troubleshoot that?
Oh, for troubleshooting.
I mean,
see, there is also a concept of acknowledgement. Like suppose say if the consumer has consumed the data and if he wants to send that acknowledgement, the acknowledgement can happen, or else explicitly you need to handle the logging details. In the server only, you need to handle the logging details, because as your point is correct, because the producer produces the data, it is available. If the consumer is not able to consume, we need to debug how exactly it is happening. Correct? That's your question, right?
yes.
Yeah. So in this scenario, like we need to handle the logging details using from the Kafka server only. There are certain mechanisms from where you can get the log details to get to know where exactly the error has happened. But because producer is running independently, consumer is running independently. Both of them are trying to connect to the Kafka server. If the Kafka server itself is down, the consumer cannot consume the data, even though the producer is running. Because producer added the data and producer is running. The Kafka server is down, then the consumer you cannot get the details through the consumer, you cannot get the details through the producer. It's only through the Kafka server you need to analyze it. So the log details will be available only in the Kafka server. Even if you are running in a microservice environment, your Kafka will be running separately, your microservices will be running separately, even if you are going to run in a Docker environment. So you need to troubleshoot only in the Kafka server to identify what is the error and where it has gone wrong. Okay, we will try one example, then you will get an idea. Okay, so the producer uses the key to know which partition to write and where exactly it has to write it. Okay, consumer, I told you, consumers can keep track of the offset and all that. This is very important. As I told, consumer has consumed till 5. Then after that, the consumer did not consume it at all. Producer is going on writing means the last message only will supposed to be coming. But the consumer will keep track of the position by the offset. It will have the offset ID so that it will get to know, okay, fine, from 6 I need to consume. Because what happens is the producer is producing, consumer is consuming, producer has started continuously writing. Now, if the consumer is trying to consume, it should not consume from here. It should consume from this particular point. So that can be done with the help of the offset ID. Consumer has the offset ID from where it has to consume. With that, so you can specify, okay, from this offset ID I want to consume, means it will be consumed. That's how the consumer works.
So consumer will also get metadata from YAML file.
Yes, exactly.
In order to identify the topic.
Offset ID. For consumer, it is mandatory that you need to provide a group ID also. Consumer cannot work separately. All the consumers belong to a particular group. Every consumer is a part of the consumer group. So it means that you need to provide a group ID, only that the consumer will work properly. Because they belong to a group. Maybe so consumers relevant to notification, consumers relevant to orders, consumers relevant to something, this. So you classify it so that like they belong to a particular group. What is the purpose? I'm having two consumers. Both the consumers are for notification. Then again, both the consumers are going to consume the same data. What is the point? So if they belong to a group, then I will get to know if one fellow is consuming it, the other one should not consume it. Okay, each party is consumed only one member by the consumer group. I hope it is clear. See, this is one important part. I hope any questions? Somebody's asked question. Oh, sorry. Yeah. We'll check the questions later on. Time is, what is the time?
And will it maintain?
No. Meeting will not end. I just check the time. Guys, actually, shall we go in for a simple example? If you guys are ready, you can do it together with me. If you are having Docker, okay, or else like quickly we will try an example. Before that, like one last part I want to finish off in the Kafka. Just have a look. Yeah, this is very important. You would have been working in traditional messaging systems like RabbitMQ, ActiveMQ. I also have worked with JMS and RabbitMQ. So what is the difference? Kafka is publish, subscribe. This is a message queue, point to point and publish and subscribe. So when I learned years before, this was something new for me. Then stores messages. It will be stored for a period of time. Message retention. Kafka has message retention policy, meaning to say that the data will be stored for a period of time. That also you can just configure it, saying that the consumers has to consume after a period of time. Throughput is very high, lowered compared to Kafka. And ordering is maintained. Ordering is as per queue, but no global ordering. And again, you just have a look. Use cases, real-time data pipelines, event-driven microservices, log processing, streaming. But here it is request response. Low latency if you want, then you need to go in for RabbitMQ. Means there should be less delay in receiving the messages. Go in for traditional messaging systems. Okay. Yes. Low latency for real-time messaging scenarios. Okay. Now, let us get started. I hope you all are having your machines. So first thing is you need to download Kafka. So two ways, if you are having Docker install in your system, you can do it in, let me just show you. You can do it in two ways. First is if you are using Docker, simple, pull, run, your Kafka is ready. So this is with Docker literally way too easy. One other way is you have to download Kafka from the net. So here, download Kafka. You can do it together with me if you are interested. Click download Kafka. It's a zip file only.
Ma'am, you don't need to download Kafka if you have Docker.
You don't need to download Kafka if you are having Kafka. Shall we do with Kafka, Docker, or like you want to do it here?
I'm asking, shall I download quickly or I have Docker?
Yeah, you can download it. You can download it.
Okay.
So here, come down. This is the place from where you need to download it. Scala 2.21. 2.12. Version is 3.9. Kafka, this one, 3.9.0. This one. Once you have downloaded, You need to extract it. Once you have downloaded, you need to extract it. So let me just
sorry, ma'am, there is two. It's 2.12 and 2.13. Which one should I?
2.13.
Okay.
This is a tar file, so you need to extract it. Let me show it from my system. Guys, if you are having Kafka, Docker, can you please put a thumbs up in the chat? If you are having Docker. Anybody else? So we will do with Docker or with this one. Okay.
Is
See,
Zookeeper separate installation?
No, actually with this only. Actually, you have to see. Let me just show you. I hope you can see my system. Let me just show you what I'll tell you the steps. First, it is in my downloads. In my downloads, let me just show you. So here you can see this Kafka 3.9.0. I extracted it again. See here. It is a zip file. Now, after this, after getting the zip file, you should not, now you need to extract it. How do you extract it? Right click, extract all you give. Please extract it to a folder which is very short. So what I did is I have extracted in C drive Kafka. So please have your Kafka folder location very short. It can be in D or C, wherever it is, the folder location should be short. No underscore, no space, nothing. Okay, I will share two commands. For people who are having Docker, you can just use these two commands. Automatically your Kafka will be up and running. Let me share it. People who are having Docker can use this command.
Using this in command line.
Yes, you can go to the command line. Your Docker should be up and running. You should go to the command line, type these two lines.
In real time, which thing will be followed, madam? Whether it's
Docker.
Okay.
Because internally Docker uses Kafka, so we don't have to explicitly run Kafka, Zookeeper server. Even when you're working in a microservice environment, you will not run it locally. You'll be running it in a Docker environment. So all your microservices, Kafka, everything is within Docker. Okay, people who are having Docker, please try to run these two lines. Automatically you will get it. People who are using, who have downloaded, please follow the steps. Okay. Now, I hope you have downloaded Kafka, extracted. The next step is create a folder. You need to create a specific folder like C drive, data, Zookeeper, any folder name, C drive, data, whatever. Just create a folder. This is for storing the snapshots. This is for storing the snapshots. So let me show mine. Here, this is my Kafka folder. I have explicitly created a simple folder with the name data Zookeeper. This is a folder. Okay, so you need to create a folder. You can give any name you want. I give the name as Zookeeper, till Zookeeper. Meaning to say that you can have this folder created anywhere. After this, okay, people who have extracted also has to do it. Please do it. You need to do this together. Data, go to the data folder and create Zookeeper. Any folder name, it is fine. Now after that, please click on config. Config. Inside config, we have zookeeper.properties. Zookeeper.properties. This is going to have the metadata information we were discussing. So click on it. This is the properties file. In the properties file, there will be a data directory. You will have a data directory with /temp something. You need to add the path. You created a data folder, whether you have created in D drive or C drive, wherever you have created, copy that path and add it.
I'm using the Docker. Is the same process for that?
In Docker, if you are using Docker, nothing else is needed. Only those two lines are needed.
What is the benefit if we add a path here, madam?
Actually, Zookeeper has to maintain the details, right? Zookeeper has to maintain the details about your topics, all that, right? So for that, when you are running Zookeeper, every time when you are running your Kafka server and Zookeeper server, it will come and check in this particular properties file where it has to store the snapshots. All the snapshots will be stored in this particular folder only. See, I have created only till Zookeeper, but automatically it has added version 2 and it is storing the logs, all the logs. Okay. If you are using Docker, you don't have to do it. Docker will take care of it internally. You'll have to go into Docker to identify that. Okay. Once it is done, now guys, you come back to your Kafka installation folder. I hope most of you are working with Windows. What I am showing is for Windows. Now we need to we need to run the Zookeeper server. So from here, type CMD. I am in Kafka 390. Okay. Now see, please. I am in this folder. Click on bin. This is for people who are working in Linux. Okay. All that your topics, Zookeeper, everything is available over here. See here. Zookeeper server start, stop. Kafka server start, stop. Can you see this? But now for me, and you want to create a consumer here, producer is here, topic is here. Everything is, you can do it from command prompt. Okay. Now for me, it is Windows. In Windows, I have Zookeeper server start. I need to run this. So I'll copy this path alone. Function F2. I'll copy this alone. Control C. Now I'll go back to the command prompt. In the command prompt, let us do it. So it is inside bin Windows. So here you cannot give it directly. /bin/Windows space, slash. Mine is not copied. I need to copy it. Come back here. Function F2, right click, copy. I cannot type it out. To avoid typos, I'm just copying this. Come back, paste, .bat. It's a batch file. We need to start the server. For starting the server, we need to give the path of our Zookeeper properties because it's having the data directory, right? So again, go to Kafka. Go to Kafka here. In Kafka, in config, I'm having Zookeeper properties. So I need that name also. Function F2, right click, copy. Or else you can just do it directly also. Now see here, space ./config. Go to the root directory. Inside the root directory, the folder name is config / Zookeeper.properties. You need to give this. I'll copy this and add it in the chat window. So your Zookeeper should be up and running in port 2181. See, the environment details are all given over here. It is taking the path also, the path that I gave, data Zookeeper, for adding the snapshots. If you have not given the path properly, you will get some error over here. If you have given the path properly in zookeeper.properties, it will give the details. Reading configuration from zookeeper.properties. If you guys have done till this, please put a thumbs up. Those who have done Docker part, that's well and good. Others, please put a thumbs up. Not able to complete or any difficulty? Then open the next command prompt. Okay, very good. Docker is up and running means not an issue at all. Your the 2 lines, that is more than enough. People who are doing it just like what I am doing, first we ran the Zookeeper. Next, we need to run the Kafka server. So it is the same thing. /bin Windows instead of Zookeeper. Now it is Kafka server start. Kafka-server-start. Right? Oh, I'm in C drive, some other drive folder, CD / let me go to the path CD kaf star. Enter CLS now.
That means we always run the Zookeeper first before the.
Exactly, exactly. First Zookeeper, then Kafka. Let me check the name of the Kafka server. Windows. Kafka-server-start. Are you guys getting it or it is running? It should be running. Just give me a sec. Let me check it out. Okay, now function F2, right click, copy.
If you're running in the Docker, where it's going to save the data, like the way you created the data separate folder for that one.
Yeah, internally Docker has it, like you need to go and find it out. Actually, internally Docker has its own network, its way of storing it, even also the log details also. Okay. Some problem I'm getting it with this one, with Zookeeper. Technically, it has to run. I don't know. Let me just start it from Kafka, Docker. I'll just give a control C here. Docker images. Okay, now I will copy that one. Whatever I have given in the chat window for you. Okay. So you see here, someone asked, right? You are running it Docker, right? See all the properties relevant to it also is shown over here. I'm running it using Docker. If you are running it using Kafka, also you'll be seeing that Zookeeper details are also shown over here. Now it is running. Okay, what next? Now everything is same for others also. So please open another command prompt. Please open another command prompt. Go to Kafka folder where you have installed Kafka. Now the next step is we need to create a topic for working with our producer and consumer. Producer has to store the data, right? So for that, again, here we are in this, see, you can go into this folder, bin Windows. Here we are having topic, Kafka topics, function F2, right click, copy. Okay. Now we are going to create a topic. Let me just explain the flow so that it is easier for you. So first is we have installed Zookeeper. We are running Zookeeper. Then we are running our Kafka server also. See, it is so my properties was wrong. That is why server.properties. config/server.properties. If at all you are not able to run, please kindly check it. I'll just copy this one and I will share it. Server.properties. Let me share it in the chat window. People who are doing it with Zookeeper, you try this out. So one window you are having Zookeeper running, one window you are having Kafka running. Next is we need to create topic. So for me, yes, this is running. Now in the first window, I have to create topic. So go inside cd bin, cd windows. Now from here, we are going to run the, we will be creating topic. So let me copy that. Control C, copy this, come back, Kafka topics.bat, -- create, -- topic, --
Usually in microservices, topic can be created through YAML.
Yes. Yeah.
So we are not doing that way.
Microservice means you need to create a Spring Starter project and all that. See, I'll just show you this. See, whatever you told is correct. See here. So here I have created a order producer microservice where in my YAML file, I have provided this, the name of my topic. Okay. And what is the in which server it is running? What is the key type? It is a string. What is the value type? It is JSON.
Offset, you did not mention it.
Offset, I have not added. You can add offset. You can add, what is
headers.
It? Partition, replica factor. Yeah, I will show you directly there. See here. And now I'm just telling where to which one. Service implementation. Here. Send the data to topic name. I'm giving a topic name. Store it in Kafka server for others to use. You ask, no, the value, at value.
Yeah.
Partition, where I want to store, partition. But producer, it is enough that he will give the topic name. But if he wants to know what is the offset to which it is added, he can get the offset details also. See here. Now let us create the topic. Maybe let me give the topic as web topic. I have few other topics, so I have given it. And you need to provide the server, bootstrap-server space localhost. It is running in your own machine, localhost :9092. Enter. Now topic is created. So let me share this.
Is there bootstrap server name is random name or is it a specific?
It's a keyword. The web topic, sorry, I have made one mistake. Don't use double hyphen for this one. Topic name should be without hyphen, right? Double hyphen. Just give it as web topic. These are all a part of your syntax. Now, if purposefully I'll make a mistake, it has to give me, see here, bootstrap double hyphen server must be specified. So it's a part of the syntax. You need to specify what is the port number in which your server is running. Our server is running in 1992. You are doing it in command prompt, so you are giving it over here. If you are doing it in a microservice, you will be giving it in the YAML file. In the YAML file, you have given it localhost 1992 bootstrap server. Okay. Now I want to see the details of this particular topic. So instead of create, just give it as describe. Instead of create, you're just going to add it as describe. That my double hyphen topic, web topic. Enter. So you can just have a look. You asked me, no, topic, web topic, topic ID, partition count is 1, replication factor is 1, only one we are having. Configurations, topic name is web topic, partition 0, leader is 1, replicas 1, see this one. All the details relevant to your topic. If you are, well, okay, now one more thing. Please don't add any annotations, please. Someone is playing with my system, I think. Yeah. See here, while creating double hyphen create to delete a topic, to describe, to check whether it is there or not, to list whatever topics are there. These are all part of the syntax. So I hope your topic is created now. So this is the command to create the topic and to check the topic. I want to see the list of topics. Whatever topic we have created. Double hyphen list. So to see the list of topics that we have created. Now in our case, it is web topic. So you can just play around with the attributes that are available over here. Now quickly let us create the console producer and the consumer. So if you are using Zookeeper is running in one command prompt. Kafka is running in another command prompt. In the third command prompt, we created a topic. Topic is ready. Now we need to create the producer. For creating the producer, we will be using the same console. Here you are having console producer. Kafka console producer and Kafka console consumer. Function F2. So Kafka console producer. Kafka console producer. To which topic you want to add? What is that you want? What is the bootstrap server? So those three informations you need to give. See here, console producer, what is the topic and what is the server? Into which topic, what is the server? So double hyphen, topic, web topic, double hyphen, bootstrap, hyphen servers. Localhost 1992. Enter. Now it is asking you to add a message. This is a demo. Welcome to Kafka. Have a great day. So actually, the producer is producing data and sending it continuously. I have shared the consumer part directly to you.
How to do this thing in with a Docker?
In Docker also it's the same. Docker also, see, in case of I'm also running with Docker. See, my Docker server is running. In the second one, you are creating you have created the topic.
No.
No, you'll have to create the topic. See,
Okay, one second.
I have shared the code. You will have to create the topic.
Yeah, please.
See, one command prompt, you are running your Kafka server. In the other command prompt, you have created the topic. I have shared the code for creating a topic.
No, with the
Kafka
Docker,
topics.
Zookeeper and Kafka is generated by the Docker, isn't it?
Yes, Zookeeper is generated automatically and your Kafka server is running. That happens automatically, those two.
Yeah.
Then you need to create the topic. Don't give double hyphen, that alone you just take it. See here. This is the syntax. Wait a minute, I will open command prompt properly. So don't give double hyphen. I have given the syntax, same syntax there. Please copy it and try it out. So the topic is ready. The name of the topic is web topic. So I have created a producer who has added data to this particular topic, that is web topic. Now I need a consumer who has to consume it. So open another command prompt. So this is going to be my producer. This will be my consumer. And my Kafka is running, server is running separately. Now
I'm getting error while I'm trying, like it's showing like Kafka console producer.bat is not
No, you have to go inside bin windows. Have you gone inside bin windows? You have to go into their Kafka installation path. Inside that, go inside bin. Inside that, go inside Windows.
I downloaded the Docker image. I haven't downloaded the
That's
Kafka.
okay. Oh, okay. You have downloaded the Docker image, right?
Yeah.
Okay. From the image, you are trying to do it. Oh, okay. 1 minute. Oh, okay. In that case, you'll have to do to the microservice. But yeah. 1 minute, just a second. Like, let me just show this consumer part. So here, Kafka console consumer, double hyphen topic, web topic, bootstrap server, localhost : 1992. Enter. Oh, I'm in a different path again. Let me go inside the installation path. cd/ cd conf cd bin cd windows. Okay. To work with console producer and Kafka, to work with this console producer and console consumer, you need that Kafka installation. If you are having that Docker, if you're in your Docker, your Kafka server is up and running, you can work with microservices, individual services. But now this is from the command prompt we are doing. Have you downloaded it, Kafka? My bad. I missed that part. I will repeat. If you are working with Kafka topic, console producer and console consumer, you need that Kafka to be downloaded and installed. You don't have to run the Kafka server from there. I am not running Kafka server from there. I am running my Kafka from here only, from Docker. So here you can see it's from Docker only. But I am using the console consumer and producer from my Kafka installation. See, this is my Docker. From the Docker only I'm running it. But I'm using the console consumer and producer from here. Okay, console consumer. Now let me run it. Now it is printing whatever I have given, it is printing it over here, just like your chat.
I think we can run in the Docker as well. When I see the documentation, the Docker website.
Okay, then what you can do is I will just give you a suggestion. You can go to Docker, open Docker desktop. You will have a terminal in Docker only.
Yeah, they're saying like open shell prompt something.
Yeah,
Docker
wait, I'll just tell you. My Docker is open or not? Let me open Docker desktop. That run is there, na? From there, that play. There you will have the terminal.
Yeah, I got it.
You got it? Wait a minute. Let me open it for others also. So guys, that those who are doing it from here, you will get it like this. What if I want to get it from the first? You can open another command prompt. You can do it from here also. If you want. cd kaf star cd okay. So now I have two consumers. God. Yeah, so here I have two consumers. Now this is the second consumer that I am creating, but I want to get the data from the first. So space from hyphen beginning. Enter. So it will read the complete producer. You can see this. Now coming back to this, if I'm adding something else. So now one producer, multiple consumers. You should get it something similar to this. So here I'm having two consumers, one producer. Let me open. Docker. Anybody got this one? Like whatever I'm showing?
Yeah, I able to create the topic in the Docker.
Yeah, very good. Okay, then let me open my Docker. Yes, exactly. It's like socket programming, but it is real streaming, even streaming. Just like your chat application, what you would have done in your Docker is not.
Is your Docker image running?
Yeah, my Docker image is running.
Yeah, you can just open the command prompt and go to that location.
No, actually the problem is my Docker is not even coming. You can do it from the Docker GUI only. This is my Docker GUI here. It's up and running, but my command prompt is having a problem. My Docker, I don't know, my desktop suddenly it is crashing. The task manager, I'll just kill the Docker.
Can I share my screen to have the Docker?
Yes?
Can I share my screen? I have the Docker so that you can do that.
No, my Docker, this thing is done. But the other one is working. My Docker crashed. Just to open, I don't know why. Okay, so I hope you guys got an idea about Kafka. Yeah, finally my Docker has started. Let me share the screen. Containers. So this is my Docker container. Here in the bottom, we have the terminal. So this is the one you told, right? From this terminal.
I'm using the external terminal. They provide some command like Docker command. I think you can run from here as well.
Yeah, yes. You have the terminal here. So from here
Yeah.
only you can just run the commands. So for console producer and for console consumer, you're having?
Yes, I added both of them. Yeah.
Okay.
I will share that one.
Okay, so I hope, yeah, the executing an external file, right? Okay, fine. Okay, guys, I hope the session went on well. Any questions? So I just wanted to tell you a few things like how many of you are working in microservices? Anybody? Spring Boot or microservices? Anyone working in Spring Boot microservices? Okay.
Spring Boot, madam.
Yeah, okay. So I am starting with a fresh batch of microservices. It's a 4 weeks training where I have included Kafka also as a part of it. In that case, like we will be doing as microservices, like Kafka will be included as a microservice. Let me share the screen about that course outline alone. So these are the topics that we will be seeing. 4 weeks training. So this is actually a weekend training between 3 to 6. So first we will do a spring-data-jpa application just to get the hand holding of working with data-jpa. It's not the basic one, but including all the configurations like one-to-one, one-to-many, many-to-many, element collection all put together, and how to do work with projections, custom queries, derived queries, and named queries. So this will be the basic setup for our microservice application also. Then we will get an introduction to microservices. Then mainly the design pattern, key components of microservices. We will discuss about the design patterns of microservices, exclusively Saga design pattern. Then how to do communication between microservices using REST template, using Fiend client, The third one is our good old Kafka. How now it's not like a simple basic application, but we will do it as a part of a complete end-to-end application. Meaning to say that the first week is spring-data-jpa, the second week is completely microservices. In the third week, we'll start creating an application for an e-commerce one. So the project setup, you will create the catalog service, you will work with gateway API, config servers, creating config servers, working with profiles and actuators, how to handle fault tolerance, then how to work with event-driven microservices. I showed you a part of it here. We have got it. Like, so this is for fault tolerance, this is for communication between microservices, and communication between two microservices as not as APIs, but using event-driven communication. Then how to Dockerize your microservices. In this case, no Eureka registry, all the microservices will be up and running with one single command, Docker Compose up. All the microservices will be running. So this is the project that we will be doing that time. So if you guys are interested about this microservices training, I will share the details. I will also share a WhatsApp link. If you are interested, you can join that WhatsApp group. I will be conducting webinars on and off. You can join the webinars. If you are interested in this microservice training, you can be a part of it. Okay, what is the advantages? Just like how we have done, it will be 100% hands-on training only. Another thing is like whatever I'm giving is like more than, you can just check the course of microservice in any other platform. I'm giving it more than what others are offering, because this is this microservice training I have curated by doing trainings in different corporates. So I go as I'm a corporate trainer. Few of you might be knowing it. I didn't introduce. So might be, so I will share the link of the WhatsApp group. You can join there. I will share the details of this particular document. If you are, I plan to start tomorrow, but next week, I'm starting from next week. If you guys are interested, you can DM me. I'll share the details of the link first. Any questions on this?
May I know the timings? What times you want?
Weekends, Saturday and Sunday, 3 to 6, between 3 to 6. Because what happens is Saturday mornings, people are like, I mean, after a weekend, getting up late, so they are not able to attend. Sunday also, it is the same thing. 3 to 6 is a good timing. After 6, you can be with your family. So that is the, so we did we did a microservice workshop last week, last week, I think. So it was really good. On top of it, I want to go in for the advanced training part. So first, let me share this link. You can join the group. Let me share it, microservices. So you can, I would like to know how did you attend this webinar, like through LinkedIn or like you are a part of my community? I just want to know. You guys are a part of this community, or you have attended through LinkedIn?
I'm attending through the Instagram post.
Oh, okay, great. Okay, fine. Okay. So guys, actually, I just want to tell you a few things. Please take this opportunity. If you are a person who is working in Java, want to upskill to microservices, please grab this opportunity, because this is the course outline that I have suggested for corporates, that I have been doing it from 2019. Kafka was introduced later from 2021, so I have added that also. Even in one single startup, they told, do not use Eureka Service Registry. Deploy all the applications only in Docker. So we will be seeing that also, how to Dockerize your microservices using Docker. Then, and few of them, they have asked for how to deploy microservice. I'm planning to add that also as a part of it as well. This is a 25 hours course. Technically, it will not be 25 hours. You all know 3 hours means it will move on to 3. So literally it will come around 30 hours. This is a 30 hours course. I'll share all the details in this particular WhatsApp group. Please do become a part of this community. And on and off, we will have some webinars. You can attend that. I would like to know the feedback of the session also. Yes. Please let me know whether this session was useful. Yeah. people who are working in Java, .NET want to switch to Java, it is very well possible. It's all, I mean, we can discuss about this. You can DM me. I hope you are having my number. You can DM me. We can discuss about this, or you can connect with my team. You can book on call. So please do join this microservices training group. You will get all the details. I will share the details, the costing, the timing, the number of hours, everything. So based on that, like if you want to make a call with me one-on-one, we can just connect and we will discuss. Yeah, I will share this recording. I'll share it in YouTube. You can just watch that. Whatever we have seen is just the basic, the fundamentals of Kafka. You will get a better idea if you're working with relevant to microservices. How nicely microservices. So we have created a microservice in such a way that order service is creating and notification is consuming it by sending a mail. Would you like to see that? Yeah, I will upload this to YouTube. You can just watch it from there also. PDF actually I don't share because like it's only for the people who are attending the training because it's a long-term effort. Any more questions? Anything you guys want to know? Any more questions? Then shall we wind up? Yeah, microservices.